Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is going to use the drag and drop interface of GameMaker Studio version 2.3, and we're going to make a game called Geometry Dash Impossible Game. There are many games like it. These are the most popular versions there of Impossible Game. Is the one I know. It started way back in the Xbox 360 days, and Geometry Dash is probably the game most of you, the kids these days, know all about. So this is where it comes from. This is the original idea. I don't have a video of it, but I will show you a gameplay of it working, my version of it working in a minute here. But it's just basically a one-button game. You press a key, space bar, or a key, or maybe touch the screen if you're playing on a tablet or something, and your character jumps, and you try to avoid all the obstacles in your way, and you try to make it to the goal. And so exactly that, get to the goal without hitting the spikes, without hitting the walls from the horizontal side. Obviously you can go on top of them, but you shouldn't be able to splat into a wall of them or anything like that. And you can fall to your death as well. And what we're going to do is just put spikes off screen when that can occur, and you'll see that in a minute. So that's the idea. And so again, movement's going to occur in two different ways here, because you think of a game just like, oh my goodness, how simple of a process is this game? But we're going to do a little bit here to make this a little more complex. Part of it is because we know better than GameMaker how to do some of the physics aspects, and some of it is just because this is drag and drop, and it has to be a little more complicated to kind of get the point across in a drag and drop environment versus the GameMaker language. So the walls, the spikes, the goals, they are all going to move horizontally. The game's going to look like the player is the one that's moving, but in reality, everything but the player is going to be moving. So that's just one of those things. It's kind of like the Flappy Bird game from earlier. Like, it feels like everything's moving, but it's not. It feels like the player is moving, but the player is actually the only thing that is not moving. But the player will control the vertical. Like say, coming back to the old Outer Limits again. Like these characters control the horizontal, the hero controls the vertical, and we are going to take over the jump physics. And how are we going to do that? We're going to use the very fine kinematic equations that you see here. I know they look scary, even if you have a physics background sometimes. These are all the algebraic versions of them. But however, at the end of the day, we're just going to use this very simple one. The velocity, the speed at any time t is equal to the initial velocity plus the acceleration times the time. And we might tinker with this formula just a little bit to get it working, because you're going to see GameMaker has some, the move contact solid function in GameMaker is not as perfect as it should be, in my opinion. And so we'll have to do a little workaround, but we're going to use this formula at its core. Make everything work. Do I have another slide? Nope, that is everything. And so here is the game in action. Oh my goodness, poor guy's died 71 times already. So here it is. It's a one-button game. I have to be clicked in here. Like, why isn't it working? There we go. Spacebar. I can jump. He falls to his death. Jump, jump, jump. And then he can hit a spike. He's dead. And so let's see if I can beat my own game. That's a big one, right? There we go. I can fall down there, and then I can jump here. And I hit the goal, and finally, you finally did it. So that's the idea of the game. Here is I'm going to go through every detail for you, just, so don't worry so much about that. But as you can see here, everything's good. So as I was describing, I'm sorry, having a little video difficulty today. Something went wrong, and now I'm trying to get myself back. So here's your player character. Here's all the wall objects. Here's the spikes. Here's the goal. And notice that the game goes longer than the room is big. We're not even using a viewport or a camera or anything like that. Again, we're going to show you here in a minute here that everything is going to the left. The player is standing still, and the player will be jumping up and down. And I put these spikes just off the screen, so you don't see it, but if you went and fell to your death, you would hit this, and that's how you would know you would die. So you don't even need an outside room event or anything of that nature. Okay, so I have 4 sprites for the game, so let's go through the details of that. So I have my hero character. 40 by 40 is its size. And I did middle center this thing, as maybe if you noticed it as the game was running, that the character actually does look like he's rotating and walking along. Run this again real fast just so you can see it. So it actually looks like he's moving around. like that, right there, boom, like that. And so we're gonna, oops, oops, I somehow hit the wall underneath that. But anyway, but you can see, and then if I fall here, I'll die. Fair enough. Okay, but so, and I just made this red with more scarlet. I just made it look a little better than just a normal block, but 40 by 40, middle center for the centering, just normal collision mask, just nothing out of the ordinary. The spike is a little bit different. The spike is an isosceles triangle, 40 by 40, and I did go ahead and I used precise collision checking on this image so that if you just nick the edge of the corner here when you're trying to jump down, you don't die. You have to physically touch one of the pixels of the spike for you to die and move on to the next, or move on and try again. So I had to use preciseness to make that work. But otherwise, this and everything else in the game but the hero doesn't need to be centered or anything like that. It's just so that we rotate the hero properly, that I move the center point, the origin point of that object, or that sprite. Wall, 40 by 40, gray, upper left-hand corner, nothing special about it. And then the goal is actually 40 wide, 720 high, because it's the full screen. You go, okay, you know, like the full height of the screen. And on this one, I just moved the bounding box in halfway so that the character basically has to kind of go halfway into the goal to account for the win. And it just, because otherwise you touch it immediately. I mean, I think it looks a little better if I make it look this way and put the bounding box halfway over, presuming the character is moving left to right on the screen. But it's, again, all of these are using basically the full images for the sprites. Just a couple exceptions with the spike, with the preciseness, and then now the goal with just cutting the thing in half. So for this kind of game, that is really all we need when it comes to our graphics. You know, there's not much going on. The gameplay is where most of it occurs. So I'm coming back in here, I set up objects. I have a goal, a hero, a spike, and a wall, just like I have sprites. You'll notice I have one extra object, and I'll talk about that in a little bit, and that's there to maintain the number of deaths, because if I reset the room and reset the room and reset the room, the lives counter, or basically my score counter, gets reset along with everything else. So I'm going to have a controller object that survives. It's called persistent, and then it will maintain how many deaths have occurred since the game first started. But let's go back to the main menu room now, or the gameplay room, now that we have some of these details in place here. So I say I have my controller object in my room. Again, we'll talk about it. But now you can see I set my grid settings to 40 by 40 so that everything lines up properly. And I put my character about a quarter to a third of the way into the screen. And then I put the walls in to make it look, give you some time to figure out and get acclimated to the game. Part of the fun of this is figuring out the physics, figuring out the jump height, figuring out the gravity, and I kind of figured it out. I'm not really 100% happy with it. I'm happy for the demo, but if I were making this for real, it would be I would change things up quite a bit to make things more fun. But anyway, so I can fall through. There's the spikes on the bottom, which will kill me. Every spike will kill me. And every wall will kill me horizontally, because everything's going to be moving horizontally. So the first thing I'm going to do is move left, move this thing left, and then check to see after I moved left if it causes a collision event with the player. And if any of those objects do, then they kill you, and you just restart the room with adding to the death counter. But if I touch the goal, it's the opposite, where I put up a message box and they say you won, and then the game ends. And in your case, you would maybe go to the next level or go back to the main menu or whatever it is that your game is going to do. So again, 720p resolution is what I chose for this, so everything kind of looks nice, everything fills in. And again, the room is 720p, but the whole game is larger. There's nothing saying your game has to be inside of the bounds of the physical room that GameMaker is drawing to. And you saw, we've played this 2 or 3 times now, everything moves to the left, and so the goal eventually will be on the screen. Everything over here goes off to the screen to the left, and right now, like I said, if you wanted to make this really cool, you could just make everything destroy once they go off the screen to the left. But for now, it works fine. There's no slowdown. There's very little going on in this game, so you don't have to worry about those kind of checks and balances when it comes to frame rates and all those things that are going on. And of course, this is fully changeable, right? That's the big part. I can go ahead and change any part of this at any time. It's fully visible. The entire layout of the room, the entire layout of my level is visible to me. So if I want to change anything, I don't have to just go in and think of programming or any other crazy aspect of anything. I can, what I see is what I get, and I just can go in and fix it up there. Okay, so let's just talk about the jumping is going to be the hard part here. But everything else is relatively simple. But everything still ties into this collision counter, this death counter. So let's take a look at this controller object. And there's a reason why it doesn't have any sprite. It's just running code under the hood, behind the scenes, and drawing the live counter, the death counter, to the screen at the same time that it's living. So on create, I created a variable called deaths. I mean, that should be very straightforward. How many times have you died since you started the game up? And of course, you started with 0 deaths. And then when I go to draw this thing to the screen, I do a draw GUI, because even if I add cameras and I change anything else, I'll never have to change this code, because this draws to the window, not the game world. So and just to take over, so I don't have to worry about this, things like that, I just said set score. I used the score, the score counter inside of GameMaker, and I said set the score equal to deaths, and then use that to draw on the screen untimely demises, and then it adds the number on top of it, or it concatenates it to the end of the string, and you can see that there. There is the string that draws. It initializes to 0, obviously, and then every time I die, it keeps track of its counter. And the only thing that's out of the ordinary that maybe we've never talked about, but I definitely have used for many years here, is the idea of persistence. And what that means is that normally when objects get, when we go from room to room or restart a room, all the objects that are currently in the room are destroyed, the room restarts, and all new objects are put in place. But if we did that for the controller object, then we would reset the death counter. All it takes is to click that one checkbox, and you will see when you run the game that I'll always have 0 deaths, which the player would be happy about, but I'm not. There we go. And that's because on destruction, we lose the data, and then when it comes back, we reinitialize it to 0. But if we make the object persistent, then it only gets created one time, and it maintains all the data, and every time I die and I increase that number through other collision events and everything that occurs, that value is kept, and it's never reset to 0, and then we have ourselves a correct counter. Okay, and there you go. And so the one thing to note is that we never directly change this variable inside of the controller object. This is kind of a breakdown of, this is the problem with these kind of languages and these kinds of environments, that I wish I could just create a function or a script. Maybe we could create a script if this was in code, but I don't like writing scripts in drag and drop, where we could increment the death counter by 1 so that it doesn't seem so weird, because it seems weird that the controller doesn't maintain its own data. Like it maintains it under the hood, but when it goes to incrementing the value, it's controlled by everybody else in the game. So fair enough. So there we go. Okay, so let's talk about the spike, the wall, and the goal, because those are easy. And then we can talk, because it really is, the horizontal movement. If any horizontal movement occurs and collides with the player, you either win the game or you die. So that's very simple logic when it comes to what's going on here. So the goal, so you can't do this, I guess you can't really do this in a collision event, and I can't really use the speed to make this work right. There's a reason why I wrote all the code out for you guys here so you could see it, so I don't have to do it while I go. So here we go. So on a step event, every single game frame for the goal, I move the goal over 3 pixels to the left. Relative to where it was, move over 3 pixels. And basically whatever number you put in here needs to be negative, so it goes to the left. And whatever the magnitude of the number is, that's the speed. That's the speed of the object. So like you have to tinker with all of these things, and I would stop hard coding these things if I were going to put this into a bigger product here. But I move left. I check to see if there's a hero on my position. Basically saying, this is basically an if check that says, am I colliding with a hero exactly where I am now sitting? Wherever this object is in my world, am I colliding with a hero? And if I am, then it's a goal touching a hero. And write some code, because the only way we can do this is to put up the dialog box that says you win. You finally made it. That finally is a little bit of a snarky comment, but you get the point, and then I exit the game, and this is where you would fill in to do whatever it is you need to do, go back to main menu, or whatever it is you need to do. I exit the game out. And so you'll see that between the goal and the spike and the wall, it's basically the same concept. On a step event, for the spike, move 3 pixels over, basically the same speed for all the objects. Check to see if I'm colliding with a hero, and in this case, if the spike touches the player, take that death value, controller.deaths, and increase it by 1 relative, and then restart the room. That's it. That's all there is to it when we're talking about the death of this thing. And this is the exact same code in the wall, because horizontally, the wall always kills the player. It's if there's a collision vertically, then that's a little different, because then in that case the player is touching the top of the box. You're supposed to be walking along the top of it. You are actually not jumping into it horizontally. But this code is exactly the same as it was in the spike. And that's all there is for those 4 of the 5 objects that we're talking about. That's all there is to it. You can, so the spike, the wall, the goal, just the difference in what to do here when you touch it, and then the controller, and so they all work together to tinker with the controller to touch the death count whenever they need to touch the death count. So the final step here, and this is why it's a little challenging, is how do I handle the hero? You notice there's 6 events, and there's a lot of code here, which I'll be describing here. You can see all this stuff, and like we're taking over the physics engine, and we're going to be writing our own physics and this and that and everything else. So let's discuss that in detail so you have an understanding. And at the end of the day, you'll understand how the physics engine basically does exactly what we do, what we're doing. And if you'd like the physics engine better, go ahead and do it. But there are always trials and tribulations when it comes to it. So as you saw, moving horizontally, we don't even have to account for that in the player object itself. The player always looks like it's moving horizontally. All the other objects are doing it for us, and if any collision occurs, we've already handled that. So in that way, the horizontal movement of our object is completely done. It's only how do we handle vertical movement, how do we handle jumps? And as I was alluding to when we first started up this video, this one equation is what we're going to use to handle the jumping whenever we need to jump. And so v equals v0 plus at. And the v0 and the a are going to be 2 of the variables that basically dictate how the jump works. I can show you a little bit here in a minute or so, but I can say this is the jump speed. If I press that space bar, how high do I jump initially? Like, what is my speed? And the A, basically gravity, how fast is gravity trying to pull me back down to the ground? And when you work with these 2 values, you can kind of sculpt the jump to however you want it to. So that's why I didn't spend a lot of time working on the level design, because you would want to get the physics of the jump down. What makes the physics of the jump fun before you worry about changing anything? Because if you change those settings, everything you set up in your level might be completely wrong at that point. And you'll have to go back in and set everything back up and reset everything so all the jumps are perfect and all the things you were trying for. That's why this isn't too complicated of a level. This is just a tester to get moving. But coming back here, so those variables I set up here inside of the create event of this guy, so of the hero class. So I said my V0 is 20. So basically, you're going to try jumping, and you're going to move 20 pixels per game frame when I initially jump, and gravity is going to pull me down 1 pixel per second, or 1 pixel per game frame. And that other variable, t, for time, in physics, t is seconds. And it's a continuous function and whatnot. But since we're using GameMaker and we're using game frames, basically time is going to measure how many game frames have elapsed since I jumped. And I'm going to set it to a negative value. So for my logic, any negative value that you see means that the character is not jumping, and any value of t that's 0 or positive, or I guess 0 is positive, but any positive value of t means the character is jumping. And that's how we will dictate whether or not you're allowed to jump or not. And a couple of the other details is if this thing is -1, theoretically I'm touching the ground. And if it's anything but -1, anything in the positive realm, then I know I have to be in the air, which obeys different behavior. Because, again, if I'm touching the ground, I don't have to worry about physics in the vertical realm at all, because there's no movement. It's only when I'm in the air that I have to figure out how far should I move in the next frame and make that work. So that's where this is coming from. And from these three variables, that's where on a frame-by-frame basis I can figure out what is my speed right now in this specific game frame as I'm jumping in the air. And as you could imagine, that number gets smaller and smaller and smaller as you jump, because obviously you start out jumping 20 pixels in the air, but very soon you're getting pulled down in a negative direction to get pulled back down to Earth or to the wall or just pulled down in this case. So that's what we're talking about in this case here. Okay, so moving on over to now key press. If I'm standing on a wall and I want to jump, I got to press the space bar. And so I have a key press event for that. And you notice there's a bit of code here just to handle what's going on. So there's a couple checks and balances to make sure I can jump. And so my first check is to see if, like we were discussing a second ago, is my t value less than 0? Is it a negative number? If it's 0 or positive, that means I'm in the air. I'm not allowing this character to double jump or triple jump, at least not in this video anyway. And so if the t value is positive or 0, that means that I can't jump. So I fall right out of here and I don't go on to figure out the other stuff. I just don't acknowledge the key press. So I didn't, if you want to hear me jamming on the spacebar just to prove it, it just goes jam, 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 jam. See, it doesn't matter. Once you jumped, it's like Castlevania, all the old Castlevania games. Once I'm jumped, I am fully, totally committed to the jump. There's nothing I can do. Okay, so but now if that t value is negative, now I go through the first check and I go, okay. And now there's a secondary check to make sure, just a double check to make sure there's a wall 1 pixel under my feet, so that I have that, I could push off against the wall and jump. So this is saying, and down is positive y, and relative to my position, pretend like I moved 1 pixel down. Would I collide with a wall? And in this case, you want to, because sometimes you don't, but this is saying, oh, there is a wall below me, so I can jump. And as I was discussing twice over now, I know I'm jumping if my t value is positive or 0. So I set my t value to 0, and that's it. The rest of everything I show you will get everything moving and get everything going and make everything and handle the vertical movement. And so double check here to make sure that I can tinker with the t value to get myself going. Okay, and so there's 3 different things that are going on, and I just broke them up into step, begin step, and end step only because it's drag and drop, and if I put every one of these things together into one drag and drop event, everyone's, including mine's, brains explode from just complexity. So I took the 3 different aspects of the things we need to worry about to make this thing work properly, and I just broke them up into the 3 places. The step is obviously the most important one, and let me see if I can get this up on the screen so it's a lot easier to read. Let me see what can I play with and what can I not play with here to make this a little more visible. And the logic should be pretty straightforward. Sorry if you can't read this. I will discuss what's happening. Let me zoom in a little bit. This is horrendous. But maybe you can read it over here a little bit better here. This guy right here. We can see this. Okay. So the direction doesn't mean speed or anything like that. If you don't have a speed, the direction is essentially meaningless. But what I did here is, the first thing I did here in the step event was say, take the direction variable and add 6 to whatever value's in there. And that's what I used to rotate the sprite. And so I guess I could show that now just to get it out of the way. So this is the only place where that variable, and I don't want to use image angle. So be careful, you know, like there's a huge difference between image angle and all these other different events. And what happens with image angle is if I just said, okay, change image angle, then the bounding box of the sprite is going to be modified as the object is rotated, and things are never going to work like you want it to. And so what happens here is I set direction basically so I don't have to change my own, I don't have to create my own variable. I'm just going to use direction since it's already part of what's working under the hood for GameMaker's objects. And so in the draw event, this is how I get over the point where you say, okay, the bounding box changes if I change the image angle. Only when I'm drawing the object do I basically move the image angle to whatever direction it is supposed to be. Then I draw it to the screen, and then I put it back to 0. So it's one of those things where the entire game, the box is actually aligned to the XY axis. It's only when it's drawn for that brief moment of time that the thing is actually rotated. So it's completely something that the end player has no idea what's going on. It's only us behind the scenes. We're doing this to trick the player into thinking this. And the reason why we're doing this is so that you see those collisions. You could see that the box is colliding technically with the wall underneath it, but according to the logic, that's not actually happening because that's the draw event that's handling it, and it's not the collision logic that's thinking about that. So consider this. And there are other games where we consider this as well, because if we just rotated things would never work out like we're supposed to. So my workaround over the years, and if you have a better workaround, I would love to hear it after all these years if you know something better. Set the image angle, draw, set it back to 0, and move on. And so that's all we need to worry about here. Now we can come back and just finish up the discussion of vertical movement and call it a day. So I say, okay. We discussed if the t value is negative, that means the character is touching the ground. And we've taken care of that. And we've taken care of the space bar. We've taken care of all of that thing. So if the t value is negative, I don't do anything. Because again, it's touching the ground. We don't have to worry about vertical movement. It's already where it needs to be. It's only if this t value is greater than or equal to 0 that we go ahead and go, okay, now we have to apply some vertical movement following that function here. This kinematic equation for for this given moment in time, how fast how fast and what direction am I supposed to be moving? And so you can see here this assigned variable. This says VT is equal to VO minus A times T. What do you know about that, right? I use VT for V at time T, but you can use V if you want to. And I'm just doing this equation. And what comes out, this VT value, is the vertical speed at this moment in time that the character is supposed to, to go. How far are they supposed to go in the vertical direction? If it's a positive value, it's going to be up, and if it's a negative value, it's going to be down. And I don't want to confuse you guys too much, but there is a difference between normal, everyday Cartesian coordinates and the GameMaker math. The y-axis is reversed, so I don't want to confuse it too much. So just follow along and everything will turn out okay. So we generate this VT value, and then we increment the t value. Because if we forget to change the time value, the character is just going to float off forever into space. We don't want that, right? And you got to make sure to make this relative, or else he'll still float off into space forevermore. So this changes the t value and makes it more and more positive, and that affects this value here. Oh, and this is a minus here, because again, I showed over here that I had to change the formula around to make this work properly in GameMaker, but it gets us to the same place. I'm not I'm not breaking the laws of physics to make this thing work. I'm just changing the way that the values come out so that we can use them properly in GameMaker. Okay, so then at the end of the day, I have my VT value. The VT value is either going to be positive or negative. And it looks like a lot, but that's all there is to this. Let me F12 this thing. Oops, I guess I can't. Oop. Let me move this over so we can see this better. There we go. Okay, so then all we do to finish this off is just to say, okay, if VT is greater than 0, I told you a positive value is up, so do a move contact solid, go up. The direction is 90, which is up, and whatever speed that needs to be. And if it's not, if it's less than or equal to 0, go down 270. and use negative. And this is the fun of the move contact solid function in GameMaker. If you tell it to move a positive amount, it will listen to you just fine. That's why this was just fine. If you tell it to move a negative value or 0, GameMaker takes that to think, oh, you wanted to move 1,000 pixels? I don't know why, but it's always been around and it always will be. And so this makes sure that we never get a 0 value and we always get a positive value. This little fudge factor here at the end makes sure that even if this VT is 0, that it doesn't end up being 0, so we don't end up going 1,000 pixels down. Because you don't want to slam into the ground at 1,000 pixels per frame, right? That sounds like it would hurt. And so if this was a perfect world, we wouldn't need any of this. We would just do move contact solid, put the number in, and it would just do what it needed to do. It's just unfortunate that this is the case. So that's all there is to the movement. If VT is positive, go up, and if VT is negative, go down, but turn that negative value into a positive to make everything work out. And so that's the idea of the step event. And so that handles the majority of everything that goes on. Press spacebar, jump, press spacebar, jump, and you can see as t goes up, the value brings me back down because it's the parabolic motion you expect to see when you throw something in the air or things jump or just things are in the air. And so we basically took over GameMaker's physics engine and did our own work here to get things going. So now let's take a look at the other 2 events, and we're pretty much done with today's lecture. So one of the 2 things that we have to think of is, well, how do we know when the character is finally done jumping and is touching the ground? That's very important. And that's what the end step event means. And again, it doesn't really matter. Really, at the end of the day, it doesn't matter what of these 3 things get what. Normally, I would just put everything in one step event. And again, I just did this to break this up so it's easier for you guys to see what's going on rather than just throwing everything in there and just going, here you go, guys. Good luck with that, like some other people do with their videos. But all I need to do on a frame-by-frame basis is just check under my feet. So this time around, I'm saying, oh, is there a wall under me, 1 pixel under me at any time? And if that's true, then I set the t value to negative. We've talked about this. Any positive value means the character's in the air, and then any negative value means the character is touching ground somewhere, somehow. So that's all there is to this. If there's wall under me, set the value so I don't have to worry. Remember, coming back here, coming all the way up to here, that first if check here, if just falls through and we don't do anything, if the t value is negative. So there's no vertical, all this stuff doesn't go on. There's no vertical movement at all if the t value is -1. So that's all there is to that. And so then the other thing is, well, how do I know if I'm walking along and kind of like with Roadrunner and all those kind of cartoons, well, what if I'm walking on a wall and then all of a sudden I'm not on a wall anymore? I'm falling off. Do I have anything? Yeah, like I can, of course, I've already done it a few times here, but like this, I'm walking, and I fall. Like without this code, without my begin step code, there is nothing that you can do. It would just keep on going. It's one of those things where as long as I don't look down, I won't fall to my death. And I go, so that's basically kind of what this code figures out right here. And so what this does is say on a step-by-step basis, it checks to see, hey, what's my t value? And this says, is my t value less than 0? This means, am I touching what I think is the ground? And so if it's less than 0 negative, in my mind, I'm touching the ground. So then I can go through and make a second check. And this time I say, hey, am I not touching a wall under my feet? Because as you're moving, it's very possible that you're no longer touching ground. So I say, oh my goodness, and that's what this checkbox is for. So there's no wall under me. And so basically the logic for this is saying, I think I'm standing on a wall, but this is telling me I'm not, so let me change the t value to account for this. So the last step here, what do I see here? T equals v0 divided by a. And you're like, where did that come from? And what's nice about this, you don't have to, if you ever change this, ever change your settings for your gravity and all that stuff, you never have to worry about this. But what happens here is by doing v0 divided by a, you've essentially put the character at the apex of the jump, which means that all the character can do is go down. Because when I fall off something, I don't jump, right? I fall. So by setting the t value to the apex of, like you said, think of a jump like this, right? If you can see this on the screen, I jump. Basically, take me to this point here, so that when I start, all I do is fall. So the t value would probably be 20, just based off the fact that my v0 is 20 and my a is 1. And no matter what two values I choose, as long as I make sure they're positive values, I never change that inside my create event, then everything will, see, yeah, 20 divided by 1 is 20. That basically sets t to 20, so I just fall and I don't do any jumping when I'm not supposed to. So that handles everything. That handles everything pretty well here. Got all the deaths, the death counter is counted for, the jumps are handled smoothly, your character's never getting killed touching a wall the wrong way, and I fall off, and all of the other things that I need to worry about. I touch the goal and I win. And like I was saying before, if I change this and I make this 32 and I make this 1.2, how does that affect the physics? Woo! You can see how that affects things. And you're like, is this? And so you're saying, like I was saying, like, figure out your jump physics before you worry about your level design, because all you have to, and you can change all sorts of stuff. Okay, make it 3, 32 and 3. What does this do to my jump? Gravity is really, it's pulling me down quick. I don't think I can even get through this jump anymore. Nope, it's impossible to get through that jump with these values. Never touch the t value, but you can play with v0 and you can play with a to your heart's content to get the jump that you're looking for. And the other setting that you need to worry about is going in, and it's unfortunately you have to do it for all the object types that aren't the hero. Let me get back here. Is how fast is everything moving in the room? And that just comes down again to this value right here in the jump to point. If you would have to go in and change this for the goal and for the spike and for the wall. And now the whole game is moving a little bit faster. You can see it, right? And there you go. And so now it changes all the tolerances for when do I jump and what do I do and how do I do it. Made the game a little easier, actually. You would think speeding things up would be more difficult, but in this case it was easier. So that's where the designers would go in, and as a professional software developer, I would create ways where they could go in and change these without having to go into the code and have to remember this. And that's not a today lecture. That's for a more, let's say, more professional. That's more of a 2D scripting kind of discussion than a 2D game development discussion. But that very much covers what I wanted to go through when it comes to this game, because you have the basics. You have everything. You got a character that moves, and you've got depth, and you've got a goal. And so now the sky is the limit. Now you know how to make the next killer geometry. What was that? Geometry Dash impossible game clone. And now you have the basics. So if you have any questions, as always, swardb@cod.edu. Great way to get a hold of me for any questions or comments or anything like that. And also, you can comment below here on YouTube. I'm looking forward to the next videos. I'm going to make not Geometry Dash, but like an old Geometry Wars Twitch 2-stick shooter. I'm not going to use controllers, unfortunately. But that's the next video that is in my series here. Hope to see you there. Thanks, everybody. Have a great day.